This lesson is on hyperbolic functions. So our first hyperbolic function is the hyperbolic sine, which we call SINHX. I usually pronounce that sinh x, and that is defined as e to the x minus e to the negative x over 2. So what does that look like? What does that function look like? If we take a look at Zoom, at Desmos, here's our graph of sinh x. And I will also go ahead and graph y equals e to the x minus e to the negative x, all divided by 2. And you'll see that it's the same function. There's e to the x minus e to the negative x over 2. And there is sinh x. And you can see that they are the same function. So that's called hyperbolic sine. Hyperbolic cosine is similar, is e to the x plus e to the negative x over 2. So let's take a look at that graph, see what that looks like. And you'll notice it doesn't look very much like cosine. It is an even function. Sinh is an odd function, so they have that in common with cosine and sine. And just to convince you, I will also graph y equals e to the x plus e to the negative x all over 2, and show you that indeed that is the same graph. There's the graph of cosh x. Excuse me, there's the graph of e to the x plus e to the negative x over 2. And here's the graph of cosh, hyperbolic cosine of x. So that's the definition of these functions. And we want to prove some basic facts. Let's first look at the derivative of sinh. What is the derivative with respect to x of sinh x? That would be the derivative with respect to x of e to the x minus e to the negative x over 2, which would be the derivative with respect to x of e to the x over 2 minus the derivative with respect to x of e to the negative x over 2, which would be 1/2 derivative of e to the x minus 1/2 derivative of e to the negative x. What do we get? We get 1/2 e to the x minus 1/2. What is the derivative of e to the negative x? The derivative of e to the something, e to the something, e to the negative x times -1. So then what does this become? Is that something that we can use? Is that something we can analyze? So we're here. What are we going to say? Well, what is the derivative of sinh x going to be then? 1/2 e to the x minus 1/2 times e to the negative x times -1 makes that plus, which can be written as e to the x plus e to the negative x over 2, which is what? Which is our definition of cosh x. So in trigonometry, the derivative of sine x is cos x. In hyperbolic trigonometry, trigonometry of hyperbolic functions, the derivative of sinh x is cosh x. And next, let's go ahead and look at the derivative of cosh x. So remember, cosh x is what? Cosh x is e to the x plus e to the negative x over 2, sinh x e to the x minus e to the negative x over 2. So that's our next thing to analyze. The derivative with respect to x of cosh x equals the derivative with respect to x of e to the x plus e to the negative x over 2, which will be the derivative with respect to x of e to the x over 2 plus the derivative with respect to x of e to the negative x over 2. Pull out the 1/2s. 1/2 derivative of e to the x plus 1/2 derivative of e to the negative x. And we get 1/2 e to the x plus 1/2 times the derivative of e to the negative x is e to the negative x times the derivative of negative x, which would be -1, which gives me 1/2 e to the x minus 1/2 e to the negative x, which is e to the x minus e to the negative x over 2, which you will recall is the definition of sinh x. So the derivative of cosh x is sinh x. Notice this is a little different. In trigonometry, circular trigonometry or triangle trigonometry, the derivative of cosine is minus sine, but the derivative of hyperbolic cosine is hyperbolic sine. So we have these facts, and there's one more basic fact that I want to look at. And that is our fundamental identity. I mean, why is this called hyperbolic trigonometry? Well, this next identity gets to that for us. So we're going to examine cosh squared x minus sinh squared x. What is that? That is e to the x plus e to the negative x over 2 squared. Now I want to go minus sinh squared x, or sinh x quantity squared, which will be e to the x minus e to the negative x over 2 squared, which is going to be what? Square the top, e to the x plus e to the negative x squared over 4, minus, similarly here, e to the x minus e to the negative x squared over 4. So what is e to the x squared? Well, e to the x times e to the x is e to the 2x plus twice e to the x times e to the negative x plus e to the negative x times e to the negative x, which is e to the negative 2x over 4, minus, similarly, e to the x squared is e to the x times e to the x, or e to the 2x, minus 2 times this, minus 2 e to the x. And then negative e to the negative x times negative e to the negative x is plus e to the negative x times e to the negative x, e to the negative 2x over 4. So we could make this all over a single fraction. What do we have? E to the 2x plus. Now, e to the x times e to the negative x is e to the 0, or just 1. That becomes 2 plus e to the negative 2x minus e to the 2x minus 2 e to the x times e to the negative x is e to the 0, which is just 1, plus e to the negative 2x all over 4. So now what does this become? What does this become? E to the 2x minus e to the 2x is 0. 2 minus negative 2, 4. E to the negative 2x minus e to the negative 2x, 0, 4 over 4, which is 1. So here is our fundamental identity for hyperbolic trigonometry. Fundamental identity for hyperbolic trigonometry is cosh squared x minus sinh squared x equals what? Equals 1. So you'll notice this is similar in a sense to trigonometry, which said cos squared x plus sine squared x equals 1, except this is cosh squared x minus sinh squared x equals 1. I want you to remember from triangle trigonometry, if we define something parametrically in terms of t or theta, for example, if I have the x value is cosine t, and I have the y value is sine t, what does that construct for me? That constructs the unit circle, a circle of radius 1. And I pick some value t here. This point is cos t sine t. And why is that? That's because cos squared t plus sine squared t is 1 in circular trigonometry or triangle trigonometry, which would be equivalent to the unit circle. Cos squared t is x squared plus sine squared t is y squared equals 1. Well, if we are working in hyperbolic trigonometry, we have x is cos t and y is sinh t. And what is our fundamental identity here in this world? It is cos squared t minus sinh squared t is 1. So cos squared t would be x squared minus sinh squared t minus y squared equals 1. And what would that give us? Not a unit circle, but a unit hyperbola. What does that look like? And the transverse axis here is horizontal asymptotes going like this, asymptotes going like this. This point is 1, 0. This point is negative 1, 0. And we get our unit hyperbola. That's why these are called hyperbolic functions. So let me go ahead and remind you of our 5 most important facts about hyperbolic functions. First off, definitions. So facts that you want to add to your collection. Cos x is e to the x plus e to the negative x over 2. Sinh x is e to the x minus e to the negative x over 2. Derivative of sinh x is cos x derivative of cos x is sinh x, and then our fundamental identity, cos squared x minus sinh squared x equals 1. So you'll notice some similarities to triangle trigonometry and certainly some differences.